office in Wilmington, North Carolina. I'd like to welcome everyone to this military installation coordination workshop today. We truly appreciate your time and your participation, and we look forward to a productive discussion. At this time, I'd like to turn the mic over to Lisa Clark, who is our Regional Study Outreach Team Lead, to review some housekeeping items. Lisa?
Okay, thank you very much, Pam, and good afternoon, everyone. Welcome and thank you for joining us today. This meeting is being recorded and will be available on our website mid-January, and I've already hit the record button. We will also conduct a few poll questions throughout the presentation, so if you could please open your chat box to view the polls. We also have a slide where you will use the annotation tool, which will appear on the left-hand side of your screen. Ms. Christina May, our environmental lead, will be monitoring the chat, and we encourage you to post questions there. We also have a hand-raising function, which you will monitor as well. During the Q&A portion, we will address as many of the questions we receive, but if we don't get to them all, due to time constraints, we will follow up later. With that, I will turn it back over to Pam Caston. Thank you.
All righty. Thank you much, Lisa. Colonel McCauley, I would like to turn the mic over to you to make some opening remarks.
All right, I appreciate it. As Pam mentioned, I'm Colonel Matt McCauley. I'm the Deputy Commander here for the South Atlantic Division based here in Atlanta, Georgia. I really appreciate, obviously, our SACS team leading this workshop with our military installations, but also all of our partners out there at the military installations for joining in this. This study, is a really important study for our division, I think for this region, because it really outlines, the future as it lays out, what are the impacts as we look at climate change, obviously storms, economic impacts, a lot of different areas as we look at the effects of climate change on our future here. So as we've gone around, I know Pam and the team there at the SACS have talked to a lot of the different cities along our southeast here, and really wanted to make sure we include our military installations, obviously because you're key stakeholders as well within our region that could see the impacts, obviously, of climate change as we look at the future. So with this study, they've got a lot of good future modeling, and the goal of this study is obviously to help communities and installations, as well as the Corps, as we look at future projects that we're going to potentially have to do. This study helps provide some of that analysis you can use as a base to protect in the future. What are some of those economical impacts? What are storm impacts as we look at the future? So really encourage everybody to hopefully have some good dialogue, ask a lot of questions, and hopefully ask RFIs, or if we need to get some answers for you, but really to help shape and dialogue that discussion and really provide you, as kind of a customer within our region, make this study worthwhile and something you can use going forward once it's concluded. But with that, looking forward to the rest of this workshop. Thanks.
Thank you, sir, very much. We appreciate your participation and your leadership today. And again, thanks as well to everyone who's on the phone lines and on our webinar for joining us today. The South Atlantic Coastal Study, known by the acronym of SACS, has been underway for about 2 years now, and we've made a lot of progress in the development of study outputs and technical report products. Now, as key stakeholders, partners, and customers within the SACS study area, our goal today is really to ensure that you have an awareness of the study and the data, products, and outputs that are available to support your site-specific efforts to address the future risks brought on by the uncertainties of climate change and sea level rise. Our study team is comprised of a regional command center team supported by fully staffed project teams in each of our 5 districts within the Corps of Engineers South Atlantic Division. We'll introduce those folks as we move through the workshop today, and their contact information is also included on the final slide in this slide deck. So please feel free to reach out after this workshop for more information or follow-up discussion. We're also very pleased to have Dr. Kate White, who is Director of the Corps of Engineers Climate Preparedness and Resilience Community of Practice, with us today to provide you with an overview of the DoD Army Climate Assessment Tool that's also available for your use. So we've definitely got a lot of ground to cover this afternoon, but we're going to still try to ensure that we carve out some breaks for Q&A as we move through the agenda. So at this time, I'm going to turn things back over to Lisa so we can see who we've got with us participating virtually today. Lisa?
Great. Thank you very much, Pam. Let me go ahead and go to the next slide here. Okay. I've allowed all to annotate, so if you could please place a mark in the box indicating what organization you represent on the left-hand side of this slide. To do this, you'll click the Annotate tool in the bar on the top of your screen. A vertical toolbar will display on the left-hand side. You'll click on the Pen/Pencil tool, which is the sixth option on the toolbar. In addition to your organization, we ask that you please place a mark on the location where you are from on the map on the right. We'll take just a few moments to do that.
So it looks like we've got a lot of representation from the Army, some from the Air Force, the Marine Corps. We've got a lot of other representation, some from the Navy, and it looks like everyone is kind of located scattered throughout the study area. So welcome.
Okay, if we're ready to go to the next slide. By the way, if you've had any issue with the annotations, please go ahead in the chat and let us know that you're there and who you're with. So thank you. All righty. So as a truly regional study, the South Atlantic Coastal Study Area covers the tidally influenced portions of the coastline throughout the Corps of Engineers South Atlantic Division's area of responsibility. So this amounts to over 65,000 total shoreline miles, including Back Bay areas throughout the 8 states and territories of North and South Carolina, Georgia, Florida, Mississippi, and Alabama, as well as the territories of Puerto Rico and the U.S. Virgin Islands. Next slide, please. Now, the South Atlantic Coastal Study was authorized in the Water Resources Development Act of 2016, and funding was received a couple of years ago in 2018 to initiate work. We have 4 years to complete the study through approval of our final report by our division office in August of 2022. Now, the charge set for the study team by Congress includes the identification of regional risks and vulnerabilities associated with sea level rise to infrastructure, populations, and environmental resources throughout the study area, and the development of measures to address this risk, as well as a long-term strategy to enhance regional resiliency. Now, SACS report conclusions, products, and data are and will be available to enhance your site-specific efforts to plan for and adapt to continuing climate change at your facility. Now, although the SACS study scope does not provide for a detailed assessment of risk on military installations, the DoD Army Climate Assessment Tool, which Dr. White will discuss later in this workshop, does provide you with the capability to get a clear understanding of site-specific risk assessments down to the installation level, identifying the climate change factors driving that risk, which will then assist you in determining which SACS technical reports and data sets will be most useful in the further refinement of your risk reduction and resiliency planning efforts. So in this way, these products and tools work together really to provide you with powerful support in preparing for future uncertainties. So at this time, I'd like to introduce Mr. Matt Schrader, who's our SACS Command Center team lead for plan formulation, to give you a bit more detail on the overall SACS study outputs, program, products, and findings to date. Matt?
All right, thanks very much, Pam. Next slide, please. So we wanted to start this section with a short poll to gauge where installations are with completing their own risk assessments, and particularly to coastal storm hazards as a result of sea level rise. So this isn't an official poll, but just something to gauge which data and SACS products may be useful to installations and ongoing and future efforts. So the poll that you should be able to see very soon on the right-hand side of your screen, it's going to be open for 1 minute. So please go ahead and make your selection. Don't forget to hit the submit button in the lower right, and then we'll post the results before we proceed.
Okay, Matt, we just have just a few more seconds before the participants finish submitting their responses. Okay, I've published the poll results.
All right. So quite a few no answers, but the ones who did answer looks like there's just pretty good across the board answers. So as we go forward, looks like there's some good variability in the utility of the tools that we're going to cover today. So just keep an eye out for some of the products that we're going to go through. Think about how they might be useful to your ongoing and future efforts. So next slide, please. So to begin, I wanted to provide the overall SACS study goals. And Lisa, let me know if there's a lag. I'm not showing the next slide yet.
Yeah, I do have it on SACS study goals.
Okay. I want to call it a couple that are particularly relevant to this part of the presentation regarding key products and shared tools and how they're helping assess and address coastal risk. So the number one goal hits on the relevance of SACS. Throughout the entire study area, numerous coastal communities have carried out their own risk analyses with various levels of detail, some very detailed, some not so much. However, what the SACS does is it provides a comprehensive risk assessment that uses a consistent application of data across the entire study area, that entire 65,000 miles of shoreline, more or less. And this is important for decision makers at state and federal levels, particularly to identify the most at-risk locations so that they can focus resources and efforts as noted under goal number 2. So for stakeholders at all levels to do this, goal number 5 on the slide is key, and it's really what we're going to be hitting on in the next several slides. This is the development and provision of what we refer to as shared tools. These are basically foundational elements that every study and design effort needs to assess and address risk. Also under goal number 5, the SACS is emphasizing regional sediment management as a way that we can improve the sustainability of current and future projects. Finally, goal 6 is for SACS data and products to be useful right now to inform ongoing efforts, and also for those ongoing efforts to inform SACS findings and recommendations. Next slide, please. So this slide provides an overview of how the SACS will organize information. It's very similar to the North Atlantic Coast study, which you may be familiar with as the comprehensive study that was completed by the Corps in 2015 in response to the devastation caused by Hurricane Sandy. Again, similar to the NACS, the SACS main report is going to house what we refer to as the Tier 1 risk assessment. Trevor Lancaster is going to provide some background on the Tier 1 viewer. It's shown on the right side of the screen later on. But the Tier 1, what it does is it indicates potential risk from storm surge inundation. but it does not take into account ongoing plans to address that risk. So we recognize that some of the slides that we're going to show today may indicate risk that installations are already planning to address, and coordination on those plans is part of today's intent. Similar to the North Atlantic Coast Study, the SACS main report will summarize output from key products such as the Tier 1, as well as data and recommendations from the more detailed state and territory appendices. So these appendices, there's one for each state and each of the 2 territories, will include what we call Tier 2 risk assessments. These are more detailed analyses for each state and territory that refine and build on the Tier 1 results. Appendices will also be the location where actionable risk reduction strategies are identified in focus areas. And focus areas are generally those locations where we're seeing the greatest risk. Finally, all key products supporting the study will have technical reports, which will be referenced by the main report and appendices. Next slide, please. So this next slide will provide some findings to date that are resulting from those Tier 1 and Tier 2 efforts that I just described. Number 1, there is significant risk, and that risk will increase with sea level rise. There will be significant need for follow-on actions and studies by the Corps and all stakeholders. Tier 1 and 2 analyses result in over 700 high-risk locations across the entire study area. As I said, the risk is significantly increased by sea level rise, particularly in what we refer to as back bay areas. These are generally encompassing any areas that are landward of a barrier island. The figure in the upper right is the Tier 1 risk assessment output for the Tampa Bay area on Florida's Gulf Coast, and MacDill Air Force Base is within the yellow circle in the middle of the figure. The colors indicate the potential risk in today's existing condition, with green indicating potential low risk, and amber and red indicating medium, high, and high potential risk. Next slide, please. So as we go to the next slide, you can see how those higher risk amber and red colors expand in the image, which is the future condition, which includes 3 feet of sea level rise. Risk in areas like Tampa Bay is also increased by compound flooding, where storm surge impacts, like we see in the image, are combined with rainfall and other factors. And the need to better understand compound flooding issues is being heard throughout the entire study area. And the SACS findings underscore the need to better understand and apply compound flooding effects. So as the complexity and risk footprint increase, this concept of joint responsibility becomes more and more important. Joint responsibility is essentially that problems of this scale can't be solved by one agency or one stakeholder, but that coastal storm risk management is a shared responsibility, and we believe there should be shared tools used by all decision makers to assess risk and identify solutions. This quote came from the North Atlantic Division's commanding officer regarding the importance of the North Atlantic Coast effort, and the SACS is also emphasizing the core ability to help stakeholders with technical assistance through programs like planning assistance to states and other authorities, as well as using shared tools like the Tier 1 risk assessment to help stakeholders advance their own efforts to reduce risk. Next slide. So the Tier 1 and other shared tools and products are shown on this placemat. It was provided as a read ahead. And I'm going to briefly cover a few of these, and you'll see applications of several products later. As we go through them, again, keep an eye out for how they might be useful to installation resilience efforts, and feel free to type any questions in the chat box so we can provide more detail during the Q&A session later. So circled in red is the identification of priority environmental areas at the bottom of the screen. This is being accomplished with SACS tools as well as other regional and state and territory specific data. At this point in time, 263 priority areas were identified throughout the entire study area, indicating the relevance of natural areas in the Southeast. These areas are ecologically and economically important and are at risk to storm surge, inundation, and sea level rise. A technical report describing the analysis used to identify these at-risk locations will be available to the public in late spring of next year. For additional detail, a link to a web map that goes into the methodology that was used is going to be placed in the chat box, so you can check that out for more detail. The measures and cost library at the top right of the slide in the red circle is another product that all stakeholders are showing a lot of interest in to help them develop rough order of magnitude cost ranges for risk reduction measures. The library contains over 40 measures, including structural measures such as seawalls and elevation of roadways. It includes non-structural measures such as floodproofing and elevating structures. Also included in the library are natural and nature-based features, which include creation or restoration of wetlands, reefs, and other natural features to reduce coastal storm damages. Installations in the Southeast are showing increased interest in these types of nature-based measures given their geographic settings, often surrounded by existing natural features that currently provide risk reduction. The Coastal Hazard System, or CHS, is another key product shown at the top of the slide. And I'm going to go into some detail as we move to the next slide, please. So the Coastal Hazard System stores comprehensive, high-fidelity numerical modeling storm responses, such as water levels, wave parameters, and these can be easily accessed and plotted through a user-friendly web tool that's accessible at the address on the lower right side of the screen. This is a really unique data set that provides a consistent regional overview of coastal storm hazards, including the effects of sea level rise, by following a common methodology for all basins. For SACS, this was completed for 3 different basins. They're shown on the right side of the slide. They include Puerto Rico and the U.S. Virgin Islands, the Southeast Atlantic, and the Gulf of Mexico. The CHS data has a number of potential planning and design uses, with some examples that are shown in the upper left of the slide. 2 core studies in Puerto Rico are already making use of the available time series data, and annual exceedance probability, or AEP values, from the Coastal Hazard System can be used to visualize inundation risk, as well as for engineering design of risk reduction measures. Regarding schedule, the Puerto Rico and USVI study region is complete and should be on the website by the end of April for public use. The South Atlantic Joint Probability Analysis is now complete, and the Gulf of Mexico analysis will be coming in soon. So those data should make it to the website by the end of August for stakeholder use. I want to emphasize that these key products are already being used by the Corps and are being requested by stakeholders to inform their ongoing efforts. So we aren't waiting until study completion a year and a half from now to support needed actions and realize SACS goals. Along those lines, regional sediment management is a practice that allows the Corps and stakeholders to do good things with the millions of cubic yards of sediment that we're dredging from navigation channels and other sources. In the Southeast, risk from coastal storms and sea level rise ultimately comes down to elevation. Basically, sea level is rising and the land is not, or worse, the land is subsiding. So using dredged sediment to increase or maintain upland, marsh, and beach elevations as sea levels rise offers numerous benefits, and Dr. Clay McCoy is going to present some installation-specific examples next. And with that, I'll hand it over to Dr. Clay McCoy.
All right, thanks, Matt. Lisa, can you hear me?
Yes, I can.
All right, perfect. All right, I'm Clay McCoy, Acting Director of the RSM Regional Center of Expertise, and I manage the SAND and the 2020 RSM Optimization Update project. SAND is a 50-year SAND needs and available SAND sources assessment for all beach projects in the South Atlantic Division, including Puerto Rico and the Virgin Islands. The project took a little over a year, and it was completed in September. The team used a collaborative approach to execute the project with over 12 state and federal agencies led by technical experts from all 5 districts of the Corps of Engineers in the South Atlantic Division and a contracted coastal engineering firm. We feel this is an excellent resource for anybody involved in beachfront management, and it can be used to support feasibility studies, environmental assessments, and sand searches. The results indicate, as illustrated on the map to the right, we have several areas across the region that don't have the sand resources they need to support their future needs. And if you're in a county that is either red or orange on the map, you have a sand deficit over the next 50 years. The report also provides several recommendations, and the major themes of those recommendations were to develop strategies to find additional sand sources and to be more efficient with the resources we've already identified. All right, next slide, please, Lisa. All So here's an example of some of the products highlighting Brevard County, which is home to Patrick Air Force Base. The report is currently on the SACS website and a comprehensive geodatabase and documents database that includes all the information and supporting information presented in the report will be publicly available very soon. We have maps at the regional, state, and county levels for all the beach projects and sand sources, which are primarily RSM sources or offshore borrow areas. We also have supporting tables that document the 50-year sand needs, available sand sources, and the balance at the county level. So in this example for Patrick Air Force Base, we documented a 50-year sand need of 3.2 million cubic yards, which is relatively small compared to Brevard North Reach, which is a 25 million cubic yard need over the next 50 years. So at the county level here, we have a 5.8 million cubic yard sand deficit, but they do have over 32 million cubic yards of sand that has been identified and several options to search for sand in the orange polygons on the figure that we classified as unverified plus, which means there's a level of data to suggest that sand resources are there, but not enough information to provide a volume, and further investigation is needed. Next slide, please. All right, so we have a poll question. Do you currently engage in regional sediment management and beneficial use of dredge material practices? So the choices are A, yes at your installation, only, yes in partnership with other stakeholders, no, but you have potential, and no, and we have no significant dredging or sediment movement activity. All right. Lisa, do you want to move on to the next slide and we'll just see how they answer? Or?
Sure, I can do that, Clay. We've got about 30 more
responses so far. Come on. All right, so I'll go over this slide real quick and then we'll look at the results. So the 2020 RSM optimization was completed in February, and it's a great complementary product to sand. Sand tells us where we have the needs, and the optimization provides several solutions to address those needs for beach as well as estuarine and riverine environments. The optimization documents currently executed and potential RSM and beneficial use placement strategies for over 70 navigation and flood risk management projects within the division, with a direct emphasis on project budgets and costs and value provided through those RSM solutions. The report highlights beach and nearshore placement, numerous pilot projects over the last couple of years, including some of those nearshore placement projects, as well as thin layer placement, and we also have some bird islands that should be going to construction very soon. By putting out this comprehensive review of what we're doing across the region, anybody can see what their neighbors are doing, which has really supported innovation, collaboration, and lessons learned across the Corps of Engineers. And we hope that this report could serve a similar role for our partners and stakeholders. So, Lisa, I'm not seeing any results on the poll. Are they there? There we go. We didn't have too many responses, but most of them were yes in partnership with others. So, thanks for those responses. And Lisa, you want to go to the next slide, please?
Yeah, one moment, please.
All right. Okay. So if you work with Kings Bay, I hope that you responded that you are implementing RSM at your installation. Kings Bay is a nuclear submarine base in St. Mary's, Georgia, and their dredging program is managed through a collaboration between Kings Bay, NAVFAC Southeast, and the Jacksonville District. We're dredging and placing around 300,000 cubic yards a year on beaches at Fort Clinch State Park and Nassau County, and the RSM strategy and partnership provides an annual value of about $4.5 million by providing sand to those sites at significantly lower cost than if they were to do it alone without the Navy. In addition, we're in the middle of a DMMA study. DMMAs are the large confined facilities that hold our dredge material on land. Kings Bay is committed to the base through 2080, so we have to figure out how to manage approximately 60 million cubic yards in the sub-base portion of the project moving forward. Kings Bay has a master plan, and we're linking sediment needs to available dredge sediment resources. And the master plan identifies several suggestions for sea level rise and climate adaptation, such as storm levees, raising features, and infrastructure projects. And we have all the sediment they could ever need and more right there in their own backyard on their base. So we're looking beyond the base as well for beneficial uses, such as bird habitat creation, which is a priority for the Georgia Department of Natural Resources, and other restoration projects in the area. We've located projects that could use potentially up to 3 million cubic yards. So we have great things going on at Kings Bay, and there are opportunities to do similar types of work at installations across the region. And with that, I'll hand it off to Trevor Lancaster, our geospatial lead from the Wilmington District.
Thanks, Clay. Good afternoon. My name is Trevor Lancaster, and I'm based out of the Wilmington District Corps of Engineers. Next slide, please. We have a variety of geospatial analyses, products, and data sets in development supporting the various SACS study elements we're discussing today. Given the proliferation of web-enabled geospatial technologies over the past several years and lessons learned from the North Atlantic Coast Comprehensive Study, we're making a concerted effort to make all of the SACS geospatial products and data available via both web mapping application and the SACS GeoPortal. The SACS GeoPortal will be our study's gateway to spatial data. Here, both stakeholders and the general public will be able to visualize, access, and most importantly, download SACS geospatial data. Users will have the ability to search via category, location, geography, and topic for SACS data sets and applications. Additionally, each of the study's geospatial products will have a dedicated page detailing the methodology, data sources, and how best to apply these tools and resources. Currently, we have several draft web mapping applications available for review that are supporting our technical analyses. Our Tier 1 risk assessment, which I'll step through briefly in a moment, our Tier 2 economic risk assessment, and our environmental analysis are all currently available for review. As we finalize reviews of these data, we'll also be publishing the data for download on the SACS GeoPortal. We currently have several geospatial products in progress, including the sand availability and needs determination web application, as Clay just mentioned, state and territory appendix web applications, and lastly, web applications supporting the coastal hazard systems inundation depth grids by annual exceedance probability events. So now I'm briefly going to step through our Tier 1 risk assessment viewer, take control of the screen. And a link to this product is available on the SACS website as well as in the chat. Please use Google Chrome or Firefox if you're looking to follow along or explore yourself. The Tier 1 risk assessment follows similar methodologies used in the North Atlantic Coast Comprehensive Study, or NACS, and it serves as a foundational product for the SACS as it analyzes coastal risk consistently across the study area using national-level data sets. This product is broken out into various tabs across the top here, broken into exposure, hazard, and risk that you can step through and look at the various indices. The primary output of this product is the composite risk index. So we can step through this kind of methodology overview tab here. The composite risk index is derived by multiplying a composite exposure index against the probability of hazard occurrence. Composite exposure index in this scenario is 60% population infrastructure, 30% environmental, cultural, and habitat, and 10% social vulnerability. These data sets were sourced from national level data sets, including census population density, the Department of Homeland Security's high field database for infrastructure inputs, social vulnerability data from the CDC, and a variety of environmental data sets from resource agencies. We looked at 3 flood hazard scenarios for coastal flooding, the 10% annual chance probability event, 1% annual chance probability event, and the Category 5 maximum storm surge scenario. We analyzed sea level rise by adding 3 feet to the 10% and 1% annual chance events as well. Users can click through these various tabs and look at the various indices across the study area and get a pretty high resolution dynamically. Additionally, there's this useful tool here that allows users to see what is the driver of risk, be it a high flood probability, high density of population and infrastructure, or significant environmental resources, or a combination. So with that, I'm going to pass it back to Lisa, and I think we have a little bit of time for some questions.
Thanks, Trevor. This is Christina. I do not see any questions in the chat, so I think Lisa is going to unmute everybody if you would like to speak up if you have a question, or write it in the chat.
We do have a few minutes. Matt and Trevor and Clay McCoy just kind of gave you an overview on the SACS regional products that have been developed or are under development. So we do have a few minutes. If you've got any questions about those products. Hey, Christine,
we do have one question.
Okay.
From Carolyn Mitchell. Can you review when these products will be available?
Sure. Lisa, I'll take that on. I'll take a shot at that anyway. Our sand products, the sand report and the regional sediment management optimization reports are already available. They are on the SACS webpage. As Matt had kind of mentioned, the coastal hazard system, those data, those runs are wrapping up at this point in time. We expect that towards the back end of the springtime, we will have the wave and water level information for the coastal hazard system published for Puerto Rico and the U.S. Virgin Islands. It will be probably early summertime, very late spring or early summer, that we'll have that information available for the South Atlantic and the Gulf of Mexico basins. The measures and cost library, we do have a draft that's currently undergoing review. It's likely that that product will be available probably towards the back end of the summer, I'm going to say. Our draft report, overall SACS draft report, is going to be going out onto the street in October of this coming year for overall review. So from that standpoint, the measures and cost library will be probably timed, again, towards the back end of the study. The environmental vulnerability and at-risk resource report, that one will likely be available in the springtime. So as Matt has indicated, as these reports are published and they're available, we are going to try to get these through review, not wait until the end of our 4-year study period, which is only about 2 years down the line right now. We're going to try to make those available when we've got them vetted and not wait. So the availability dates will be staggered for these, and I think that you'll be able to, you'll find that these products will be rolling out fairly steadily between now and probably the better part of the next 10 months or so.
Okay, thanks, Pam. We did have another question. Is the presentation available to us now? And Lisa said she did attach it to this meeting invite. It will be available on our website in the next few weeks, and I did put that website address in the chat box. So I do not see any other questions in the chat. So Pam, I don't know if you want to move on to the district.
Absolutely, Christina. I think this is probably the right time to transition now into some more state and territory specific.
Okay. This is Lisa. I'm sorry, I just had to put the mute all function back on. Please stand by.
Or now? Can you hear me now?
Yes, Lisa, we got you. Thank you.
Okay, thanks, Lisa. Hi, everyone. I'm Lisa Bishop, Interim Project Manager for the Wilmington District team. You can go to the next slide, please. So our SACS planning reach, indicated here in blue, includes 10 installations categorized by color to represent the type of installation, and 7 Coast Guard stations, which are represented here in white circles. So focus areas are in red, and these will include an action strategy to address coastal resilience actions that are needed or currently in place. For our district, this includes 3 selected areas: Dare County and Ocracoke, Carteret and Craven counties, and New Hanover and Brunswick. The majority of installations and Coast Guard stations are located within a focus area, with the exception of the Marine Corps Base Camp Lejeune and those near Elizabeth City. The Marine Corps station at Cherry Point, Oak Grove, is just outside of a focus area, but the larger Cherry Point installation is within the bounds. And we've also included reported sand needs in green and existing mitigation projects in yellow, just to give you an idea of those strategies already in place in your surrounding areas. Next slide, please. Again, the Tier 1 risk assessment regional analysis identifies potential coastal risk and can be found at our SACS website. The composite risk index is displayed here, with warmer colors representing higher potential risk and greens representing lower potential risk, with the darkest green being equivalent to the lowest amount of risk. So the Dare County and Ocracoke focus area is shown here. The Coast Guard stations at Hatteras Inlet and Elizabeth City have the highest potential risk. And although the Dare County range has a lower risk, it's important to note that it's bordered by 2 priority environmental areas to the south and protected by 2 priority environmental areas on the coastal barrier that are more susceptible to sea level rise impacts. And the NOAA sea level rise viewer at 3 feet of sea level rise, it shows inundation of the surrounding area around the Dare County range, and then reduced barrier efficiency. So lower risk isn't really defined here very well. If in turn we do end up with 3 feet of sea level rise, because that particular area is more, the risk is based off more environmental factors and coastal storm impacts, not so much population. So one of the important strategies for the Wilmington District was to capture ongoing or existing actions. And the state of North Carolina has a vast amount of coastal resilience work already in progress. And for Dare County, this includes 14,000 acres of reserve under the Readiness and Environmental Protection Integration, or REPI program. So we appreciate those 14,000 acres preserved. Next slide, please. For Carteret and Craven focus area, Coast Guard stations at Bogue Island, including Morehead City and Bogue Inlet, have the highest potential risk. MCAS Cherry Point and the outlying landing fields at Atlantic represent areas of potential medium-high risk. And again, MCAS Cherry Point has over 11,000 acres of preserved natural area, including Piney Island and forested areas along the Neuse River. MCAS Cherry Point, Oak Grove, and the Marine Corps Base Camp, Camp Lejeune received 2020 REPI Challenge funding for 2,100 linear feet of living shoreline, which represents the first multi-installation agreement and new regional approach to coastal resiliency on military installations. And they have plans to continue this approach in the future with an additional 5,000 linear feet planned. Next slide, please. So this one shows the Marine Corps Base Camp Lejeune, which does include areas of all risk levels, with the risk upstream of New River and within the Bay areas where compound flooding may also be a concern. Upriver, the risk increases. Camp Lejeune, also part of the REPI program, they have over 19,000 acres of preserved area, and they're also they're partnered with MCAS for future projects. And the New Hanover Brunswick focus area sees a similar trend with risk increasing upstream of the Cape Fear River. This would also include Matsu and Fort Fisher, which have areas of medium to high risk as well. And I'm going to pause here for just a second. I saw a pop-up that said that you wanted us to point out where Onslow Beach was, and I think we can come back and do that for you in just a moment. Next slide, please. All right, so the Wilmington District footprint includes 10 installations, 7 Coast Guard stations. There are 14 priority environmental areas that often neighbor installations, and nearly all of the installations include areas of medium to high inundation risk from coastal storms. SACS products can provide a clear understanding of coastal hazard in those areas surrounding your installation, including potential hazards from flooding, as seen on the right, and economic risks, including expected annual damages as seen on the left. And then understanding those coastal risks in the surrounding area could provide potential partnership opportunities for installations. And with that, I'm going to turn it back to Lisa Clark.
Okay, sounds good. Did you want to point out where Onslow Beach is for Susan Lane?
I believe, yeah, sure. I believe if you go up, so what you're seeing on the left for the Marine Corps Base Camp Lejeune, I believe Onslow Beach is to the north of the inlet in the center. Everything to the south is going to be North Topsail Beach, Surf City. So yeah, relatively low risk. It could be that the primary driver there is either an environmental area or it could be coastal storm inundation. If it's not a heavily developed area with a large population, a lot of the times the risk will seem lower. So it's important to note that looking at the primary drivers is very important when thinking about the risks and what the impacts could be. And there's a comparison tool on the SACS webpage where you can pull up the composite and then have risk from inundation, environmental and cultural resources, and then population all next to one another to try to figure out what your primary driver may be.
Okay, great. Thank you, Lisa. And we'll move on to Ms. Diane Perkins.
Thank you, Lisa, and good afternoon, everyone. I'm Diane Perkins with the Charleston District, and we are covering South Carolina. Next slide, please. So this graphic shows installations and training areas in South Carolina. Joint Base Charleston is shown in the gray at the top of the slide. And in the Beaufort area, there are 2 Marine Corps installations in the Navy Hospital. Also, there are 2 U.S. Coast Guard stations along the coast. And in the background, you can see hurricane tracks and the extent of potential coastal storm surge inundation. Next slide, please. Okay, and so this map shows composite risk in the future condition incorporating sea level rise. Joint Base Charleston area is on the left and the Beaufort area is on the right. Red is highest risk. Yellow and amber are medium to medium high risk. And this is the same data set that a lot of other folks are showing, but we have a simplified color map here with low risk shown in blue. And even if it looks on these maps like risk on the military bases themselves is not very high, please notice that the risk in the surrounding communities is. A key part of the purpose of the SACS study is to not only provide information and tools for individual jurisdictions and installations to work with, but also to help communities work together to address these shared problems. And sometimes some of the data we have for the military installations is not as, we don't have as much data. So sometimes we might not be able to see the information as well as we can for the surrounding community. Next slide, please. And so this slide is focused on the Beaufort area, and it will have encompassed within it both of the Marine Corps installations as well as the Navy Hospital and surrounding communities. We're seeing economic risk in the present and future conditions for the communities and installations with existing conditions on the left and future conditions on the right. You can see that risk increases as represented by the colors darkening from lower risks in yellow to higher risks in orange and red. And if the colors shift doesn't appear dramatic enough, please notice that the dollar amount of economic risk nearly doubles. And you can see the existing potential economic risk in the upper left at over 85 million and the future potential economic risk at nearly 161 million. This kind of risk increase is also expected for the military installations themselves. Next slide, please. And so for the Joint Base Charleston area, we see economic risk in the present and future conditions again, and risk is increasing. And in this case, the color shifts are more dramatic, and the dollar amount of economic risk more than doubles. You can see on the existing conditions on the left, nearly 321 million, and in the future conditions on the right, nearly 701 million. And I'd like to go ahead and hand over our presentation today to Todd Martin of Joint Base Charleston, who's here with us to provide an overview on what Joint Base Charleston is doing, as well as to touch on potential opportunities for working together in the future. Todd?
Yeah, thank you, Diane.
And next slide, yeah.
Good afternoon. Just as a little bit of background, Joint Base Charleston covers over 20,000 acres. We have about 9 million square feet in building space, but more importantly, we can convey over 150,000 tons of cargo predominantly via sea lift through the Cooper River, and more than 105,000 DoD civil aircraft operations every year off of our joint use airfield. The Air Force actually owns the runways at Charleston, and the Civilian Aviation Authority, the Charleston International Airport, and Boeing both also use the runway for their purposes. Traditionally, the installation conducts annual all hazards assessments as part of our local vulnerability assessments, and that's what we use to identify current threats to our critical infrastructure, and we use that to quantify the probability of failure from each of the identified hazards, as well as the potential consequence of failure as it would impact the missions projected from Joint Base Charleston. Threats we've traditionally looked at are near term, and they focus on common hazards, whether they be natural. You saw earlier, we're very familiar with hurricane tracks. We also have high seismic activity here near us in the Somerville fault line. And then we have tornadoes, lightning strikes, flooding. We also look at accidental issues, which are waterline breaks and power outages, both on base and off base, and how that would affect our infrastructure, as well as the intentional acts of either sabotage or vandalism or criminal acts and how that would affect our mission sets. We use these assessments to frame and drive ongoing discussions about what mission sustainment risks are considered to be untenable to base leadership, and then what project requirements and process improvements we need to make to implement in order to mitigate those risks. One thing that's changed earlier this year is the Air Force has rolled out a new initiative to systematically identify exposure to severe weather and climate hazards across the enterprise. They've added a new assessment playbook to the installation development planning process. So now, in addition to the hazards we've been commonly assessing in the all hazard assessments, we're now starting to assess the impacts from current and future risks, which are less common or have longer event horizons. Some of the things that we're now in the process of analyzing and looking at, sea level change obviously is there, but we're looking at drought, fire threats, changes in precipitation, changes in the average annual temperatures, subsidence, shifts in the ecosystem, additional disease vectors, which obviously is a good one for this year. And we're also looking at some more subtle things, such as saltwater intrusion and the effect that might have on the ability for the local purveyors to provide water, potable water to us, as well as changes to the shoaling rates within the Cooper River and how that would affect our sea lift mission. Next slide. So, as Diane said, some of the things that we're getting from this study and is feeding into this new playbook and our all hazards assessments, and we're starting to look at is, again, there's portions of the weapon station that are low-lying and that do flood, especially on king tides now, and we're assessing now the increased probability and duration of this inundation events, as well as extent and the impact that would have on some of our waterfront missions. The air base itself is on the high point in Charleston County, and thus is really not susceptible to inundation events or storm surge events, but we do have some localized flooding on the south side of the air base. We saw that during the 500-plus year flood several years ago. As mentioned before, increased sedimentation rates within the Cooper River are of profound concern to us because we got to pay for that out of our facility sustainment funds to maintain river depths to allow ship movements and movements of moored training ships that we support with one of our major supporting components for the Navy. As Diane also mentioned, one of the things that we're looking at is, from a community perspective, we are heavily reliant upon the utility providers for water, for sewer, for power, for natural gas. And what are the impacts that some of this climate change and, again, in this case, how resilient are those providers in their ability to provide critical utilities to us in the event that we, again, have increased risk to storm surge or sea level rise. And then, again, as with any installation, we're looking also outwards to the number of personnel assigned to the base and to the dependents and the retirees that we serve in the population. And we're looking, again, as to the overall risk that's borne by them due to things that are being looked at with the study. So that's what I've got, Diane.
Thank you so much. It's highly appreciated. All right, so for the closing slide on South Carolina, the command team presented a variety of tools. The study team for Charleston District is using these tools, and they will be available to you in the future. And on this slide, I'm just, if you can take a look at the two blue bullet points that are prefaced with question, the Charleston District study team is posing some questions to y'all. If you can offer any thoughts into the chat box. In looking at the information from the study so far, we're wondering if regional sediment management in the Beaufort area, such as thin layer placement at marshes, could help provide some coastal storm risk management resilience to the communities and installations behind the marshes where the thin layer placement is made. So if folks have thoughts or interest on that, we'd love to hear from you. And in the Charleston metro area, we're wondering, as Todd mentioned, the Naval Weapons Station is a really important place. And the study team for Charleston District is wondering, would a coastal storm risk management study focused on the Naval Weapons Station be of interest, or some other form of study that would help that become a more resilient location? And again, you can just chat those into the chat box if you have thoughts. And there will be a question and answer session later if anyone wants to talk about the South Carolina area. But Jeff Schwindeman is presenting next for the Georgia area. Thank you.
Okay, thanks, Diane and Todd. My name is Jeff Schwindeman. I'm the project manager from the Savannah District, and we're responsible for the Georgia planning reach. Next slide. So the Georgia coast consists of approximately 100 miles of coastline from the Savannah River in the north to the St. Mary's River in the south. Geographically, we're located on kind of the westernmost portion of the concave-shaped South Atlantic bight. So we actually have a relatively high tidal range of around 8 feet. The Georgia coast is relatively undeveloped compared to our neighbors in the south. And we have several barrier islands that are in a somewhat or near natural state. So the map you see shows a bunch of shades of blue. Those represent inundation extent from various magnitude storm events. And you'll see that within that, there are several installations. So going from north to south, you've got the Air Force 165th Airlift Wing at the Savannah Airport in Chatham County. You've got Fort Stewart, which is kind of adjacent and somewhat overlaps that inundation extent. But you've also got their component, Hunter Army Airfield, located in Chatham County. You've got Coast Guard stations in the Savannah area at Tybee and then at Brunswick. Marine Corps Air Station Townsend Bombing Range is kind of on the edge of McIntosh and Long County. and then you've got Kings Bay kind of at the south end in Camden County. Next slide, please. Okay, so if we start on the left, this is a type of figure that you've seen earlier in the presentation. This is the Tier 1 Composite Risk Index over the entire Georgia planning reach. And so there's some areas in red that are high risk areas, and they're focused in our two focus areas, so Chatham County and Glenn County. And then you've also got some medium high risk area, that amber, located in Camden County. So you'll see that this kind of correlates with some of the installations in our planning reach. So if we zoom in on Chatham County, you'll see Hunter Army Airfield in the center, the Air Force 165th in the north part, and Coast Guard Station Tybee there on the far east. And so, one of the things this shows us, this shows not only the installation risk, but it also puts that into the context of the risk to the surrounding community. Next slide, please. So digging in a little bit deeper, we're going to see how some of these SACS tools can be applied to a specific example, in this case, Kings Bay. So on the left-hand side, you'll see our economic risk assessment, and this uses a FEMA HAZUS model to estimate annual damages from different magnitude events. And it also takes into account existing conditions, which is what's on the left half of that figure. And you'll see in the vicinity of Kings Bay, you've got about $20 million of annual, expected annual damages. And then on the right side of that figure, it also looks at future conditions with 3 feet of sea level rise. And that equates to about a 3-fold increase in economic risk. So one of the things you can notice from here is that an area of relatively high damages is kind of in the southeast part. It's Amelia Island and Fernandina Beach. And we already saw earlier from Clay McCoy's presentation on RSM that Kings Bay, they took something that was a challenge for them, like managing a lot of dredge material, and turned that into an asset for their community, providing coastal storm protection to those exact areas. So that's just a great example of being proactive to mitigate risk in your community. On the far right side, we're looking at environmental risk in the vicinity of Kings Bay. And so you see a lot of medium and high risk areas. And of particular note are these priority environmental areas. So those are represented by the green stars. And in the north, you've got Crooked River State Park. And then on the east, Cumberland Island National Seashore. So those are just areas in the immediate vicinity of that particular installation. Kings Bay has also been proactive with their environmental posture. They participate in the REPI program with over 16,000 acres protected and $41.2 million committed to environmental efforts over the next several years. Next slide, please. Okay, so on the left, you see a table. What I wanted to do here was kind of summarize issues and hazards that affect the particular installations in the Georgia planning reach. But, this is likely not new information for you as installation managers and planners. You're probably well aware of the risks that face your particular installation. So where I want to focus is on the right side of the slide, which is how you can use SACS products to potentially address some of those issues. So if you have, dredge material management issues, then regional sediment management could be helpful for you. We have products that we've talked about for that. If you're using these, these web portals and you notice particular communities in the vicinity that you would like to partner with, we have a coastal program guide that can help both of you do that. If you have particular issues like shoreline erosion or things that you would implement a structural or non-structural measure to address, then we have the measures and cost library. And then if you want to dig deeper into the environment in the vicinity of your installation, we have tools for doing that as well. So thank you for your time. If you have any questions specific to the Georgia Planning Reach, please let me know. And then up next is Ashley Fountain, who will be talking about Florida.
Hey, everybody. Thank you so much, Jeff. And I'm going to cover the Jacksonville District. So my name is Ashley Fountain, and I'm the Jacksonville District Project Manager for the South Atlantic Coastal Studies. Next slide, please. I see we have some questions coming in through the chat, and I'll be happy to get through those as we enter the Q&A. I think that one was about the 3 feet of sea level rise. Pam, did you want to address that now, or?
No, Ashley, we'll take those during our Q&A. Please go ahead. Thank you.
All right. So Ashley Fountain here again. The Jacksonville District Area of Responsibility covers Peninsular Florida, Puerto Rico, and the U.S. Virgin Islands. And I'll be providing an overview of all 3 today. Within Florida, as you see on the screen, we have 39 military installations in special areas. 23 of those fall within Jacksonville District and 16 within Mobile District. You'll be hearing from Meredith Ledart, the Mobile District Project Manager, here in a few minutes to cover those installations that fall within Mobile District. And also within Florida, we have 18 U.S. Coast Guard stations. For our territories, we've got 5 military installations in special areas in Puerto Rico, and 1 U.S. Coast Guard station, and 1 U.S. Coast Guard Marine Safety Detachment in the U.S. Virgin Islands. All in all, that's about 45 total installation special areas and Coast Guard stations within the Jacksonville District area of responsibility. The next slide will provide a map of the installations in Florida and Puerto Rico. Thanks, Lisa. As you can see on the slide in the 2 maps on the right, we have identified the installations and special areas. I'm sure while working for the DoD, Department of Defense, that you're familiar with the term BLUF, or bottom line up front. So the bottom line up front here is that the proximity to the coast increases your exposure to hazards. I'm sure that comes as no surprise to anyone here on the line. But the majority of the installations in Florida are very near the coast and therefore are all at relatively medium to high inundation risk from coastal storms. You can see the storm tracks on these maps from 1995 through 2020. These storm tracks within the short 25-year time frame just demonstrates the importance of the South Atlantic Coastal Study as a whole. Next slide, please. Thank you. As you have heard, SACS is evaluating the increased risk to coastal storms as a result of sea level rise. This slide is from the SACS Tier 1 risk assessment, which you've seen a few times today, depicting the existing and the future conditions of the U.S. Coast Guard Marine Safety Detachment in St. Thomas. As you can see, the risks only increase under future conditions, and for this reason, as well as being an economic hub for the territory, this area was selected as one of our 2 focus areas for the U.S. Virgin Islands. So we'll be developing actionable strategies and recommendations in this area within our focus area action strategy, and we'll also be documenting those in our USCI appendix. Next slide, please. All right. This slide walks through some of our vulnerable installations within Jacksonville District. Each installation depicted here is positioned in a way where damage reduction measures will vary based on site-specific conditions. As you can see, the Keys are different from Naval Station Mayport and Patrick Air Force Base being on a barrier island, and Homestead Air Reserve Base in Southeast Florida, where sea level rise is being seen and the effects on a day-to-day basis. So, as those damage reduction measures will vary, each installation should be able to use and learn from several of the SACS key products discussed here today, such as the coastal hazard system, in making future planning decisions. And on the next slide, I'll go into the coastal hazard system and how we're using it in Jacksonville District. The coastal hazard system is being developed, as Matt said, for all of SAD, for all of South Atlantic Division, within the 3 basins, the Atlantic, Gulf of Mexico, and the Puerto Rico and USVI basin. The CHS, the Coastal Hazard System, provides the probabilistic water levels that can be used for future planning. And the basin for Puerto Rico and USVI has been completed. So you can see the storm tracks over there in the top right, in that graphic over there. And it's already being used in our core feasibility planning study, the Puerto Rico Coastal Study, for coastal storm risk management. What we're seeing within the coastal hazard system in Puerto Rico and USVI basin, quite a mouthful, is that sea level rise, we see a direct correlation to future wave heights, as seen in the bottom graphic. So as sea levels rise, the wave, it's a direct correlation to the wave height. Another key point coming out of the CHS is the projected increased risk to back bays and estuaries. As you probably know, the Corps is and has been involved in many ocean-facing storm damage reduction projects, shore protection projects, coastal storm risk management projects. A lot of these fall along the coast, and we perform beach nourishment. But given these projected future risks that we see coming out of CHS, these back bay areas may very well be a strong candidate for future evaluation for coastal storm vulnerabilities. And so we're seeing that in a lot of our focus areas throughout Florida and also here in the territories. Next slide, please. So what next, right? So what? What's the so what? That's what we're always asked. So what can be done? Next steps, I know you've heard a lot about regional sediment management, RSM, and there's a lot of great work already taking place. Anytime an installation or we move material, always trying to figure out what can be done, what's smart, how can we keep the sediment in the system, seeing it as a resource. So I encourage you to check out that RSM optimization and sand reports. They're great tools for reading in and looking into that. And then I highlighted just environmental stewardship and sustainability because a lot of installations have a lot of land area. I think I heard 20,000 acres earlier for the Joint Base Charleston. So with that area, there's a lot of opportunity to improve sustainability and resiliency. So just the priority environmental areas, in a lot of cases, do fall in close proximity to installations as we've been seeing in Jacksonville District. So just wanted to point that out. And then at the very bottom of this slide, and just as I referenced with the coastal hazard system, and for feasibility planning, for looking at the vulnerability, assessing vulnerability, and making future decisions, we've got some tools, and I know you've seen a couple of snapshots from the SACS Tier 2 Economic Risk Assessment. You can see that here on the screen right now, and you can see the existing damages, the economic damages in dollar damages, and existing and future conditions. So one of our other SACS products that you've heard about today is the Measures and Cost Library. And one of the ways that you can use these two products together is to compare these economic damages, and you kind of equate them to damages prevented potentially from a measure, from the Measures and Cost Library to determine the economic feasibility. So using these two SACS key products and combinations is another path that we're taking in our focus areas and for within our appendices. That's the end of my brief today, and happy to answer questions later on. Thank you.
Alrighty, good afternoon. My name is Meredith Ledart. I serve as the project manager for the SACS PDT in Mobile District. So the graphic on the left highlights potential future inundation and highlights where we have our military installations, including Air Force, Navy, Coast Guard, and Army National Guard locations within Alabama and Mississippi. Ashley before mentioned the military installations that are in the Florida Panhandle that fall within our AOR. Next slide. So as several other of the project managers have mentioned, we have our Tier 2 economic risk assessment. So today I'm going to just highlight some of the potential risk that we have identified across the installations within our AOR. Up on the top left of the slide is Tyndall Air Force Base, located in the Panhandle. While there are, as mentioned before, some of the actual military structures and values that are not included in the National Structure Inventory, this is a good representation of potential existing and future risk. As you can see at Tyndall, where the future risk potentially doubles within the Tyndall Air Force Base area. Moving over to the top right of the graphic is Pensacola Naval Air Station, where between looking at existing risk as well as future risk with sea level rise, that's almost a four-fold increase. And then down at the bottom of the slide is Eglin Air Force Base, which is similar, where we're seeing a potential increase in risk of about double from what is existing. Next slide. All right. So this is the U.S. Coast Guard station in Mobile. You can see that a number of the structures within the installation are not showing inundation risk, but there is surrounding area. And so we're looking at a potential existing condition risk of about 56K versus you can see a significant increase in the economic risk in the future of about 3 times from the existing condition. Next slide. All right. And for 2 of the military installations we have in Mississippi, we have Keesler Air Force Base, which is definitely in a medium to high risk area. While not all of the installation, we're seeing inundation. Definitely there is economic risk with some of the surrounding area. And so that's almost a 2-fold increase between existing and future risk. Okay. And then over to the right of the graphic, we see the Naval Construction Battalion in Gulfport with going from existing to future risk at about double of that. Next slide. So one of the other analyses that we've conducted for our Tier 2 risk analysis includes priority environmental areas. So there were a number of priority environmental areas that were identified across our AOR in Alabama, Mississippi, as well as the Florida Panhandle. But 2 that we're highlighting today are areas that were identified within the military installation footprint, and those fall within Eglin, Tyndall, as well as Pensacola Naval Air Station. And they were identified, one, just due to what was potentially being exposed. Similarly, Eglin and Tyndall and Pensacola, they have a shoreline that is diverse, including intertidal lagoon and estuary that supports a diverse habitat as well as critical habitat areas for listed species. And in terms of the identified vulnerability, It's at risk for degraded water quality impacts to the estuarine habitat, as well as potential impacts to marine fisheries, and loss of coastal lands due to erosion from increased surge with sea level rise, as well as potential saltwater intrusion for key areas. One of the items that Tyndall has been working on, just to highlight, some of our military partners, is they have developed a coastal resilience working group implementation plan, of which the Corps is one of the many stakeholders that's participating in that, and identified a near-term and mid-term and long-term goals for, one, identifying pilot projects using natural and nature-based features, and then ways to leverage funding across stakeholders to implement those pilot projects and then evaluate their success and develop ultimately a long-term strategy for combining natural nature-based features as well as green infrastructure projects for Tyndall Air Force Base. So with that, I am going to turn over the presentation to Dr. Kate White to talk about the DoD Climate Assessment Tool.
Hi, thanks, Ashley. Meredith, would you like to do some of the questions for the district folks first before I talk, or do you want to save them to the end, Pam?
Let's see, Kate. We've got about 8 minutes. Why don't you go ahead and we'll take all the Q&As at the back end.
Okay. All right. So if you can go to the next slide. What I'm going to be talking about today is the DoD and the Army climate assessment tools. These are screening level tools that I'll be talking about, and they leverage very well the kind of detailed information you've just heard from the South Atlantic Coastal Study districts and the analysis. And I'd like to acknowledge the presence of Marissa McInnes here. She's our lead for the DoD climate resilience work, and we've worked in support of her. So, Marissa, if you want to say hello or anything, that'd be great. And if not, you can go to the next slide. Thanks, Lisa. So these are some of the requirements. I think you've heard about them earlier in the workshop today, but we have the older requirements, the Quadrennial Defense Review, the Climate Change Adaptation Roadmap, DODD 4715.21, and then lately the National Defense Authorization Acts and other kinds of memos, such as the 24 February memo, Improving Defense Installation Resilience to Rising Seas. So if you can go to the next slide. We also have Unified Facilities Criteria that have been updated over the past year. We've got the Civil Engineering UFC Change 4, which was just recently released 28 September of 2020, that includes the defense regional sea level rise scenarios and how to use those, and potentially issues of riverine flooding too. Next chart. So the idea for the Army and the DoD climate assessment tools is that there's a lot of information out there, and the department really wanted to take a look at a consistent approach that helped them prioritize further investments in climate resilience. So really what we're looking at here is screening in or out exposure to hazards using consistent, authoritative, standardized data and methods to identify relative exposure, that is, to rank the installations one against the other. You've heard a lot about the SACS studies. They pointed out specific installation locations and the kind of data that they have, and that's great data. It's the next kind of data that we have to move on to once prioritization has been made. So this idea of these tools is really to look at scarce resources, dollars, time, et cetera. Next slide. This slide will show the area where the DoD climate assessment tool fits. It's at the global scale, looking at exposure to climate hazards, most of which are included in the Air Force playbook that you heard about earlier. At the department or at the installation or at the facility scale, we'll really be looking at whether the missions and operations are sensitive to this exposure, and if they are sensitive, how might you adapt to it to reduce the impacts from climate and extreme weather. So the next, I just see in the chat the installation master planning update has been signed. Yay, I've been waiting for that. So the next slide, please. So these DoD level screening climate assessment tools cover these regions here shown in color, the CONUS, Alaska, and Hawaii, and then fewer installations in Italy, Germany, United Kingdom, Greenland, Japan, South Korea, et cetera. So this is phase one of the DoD climate assessment tool that's been released so far, and more installations are underway so that we have a wider range of data. Next slide. So the approach is to deal with 8 climate hazards: heat, drought, energy demand, coastal flooding, riverine flooding, land degradation, including coastal erosion, which you've heard about quite a bit here, and historic extreme events. We do the screening using 33 indicators. They're geospatial indicators that give us, in combination, an idea of what that risk looks like. We look at the base period, which is essentially the current period. Then we look at 30-year epochs in the future, 2035 to 2064, that's centered at 2050, and the next 30 years centered at 2085. This gives us information out to 2100 for a long-lived infrastructure. We're looking at a higher and a lower rate of warming in the future, and we're looking at 3 different geographic areas where there's CONUS, Alaska and Hawaii, and rest of the world, as I showed on the map previously. Next slide. So this is the front page of the tool itself, and it shows the different areas. We have an impact awareness, which brings the user to the latest national climate assessment or the rest of the world analog to that. We have a national standard view with default values for the visualizations. My assessment allows people to actually tinker with the default values or change the indicators to make an assessment tailored to their particular installation, or add data if they want, with their results viewed on the My Results tab. And then we have administrative functions, manuals, et cetera. And so if you go to the next slide, we have summary reports that are in the Army Climate Assessment Tool and the Department of Defense Climate Assessment Tools. These are essentially shown here. They're essentially relative scores that allow people to understand how different installations are ranked compared to others. And the reason for this is that the DoD tool is intended to be an overall look at relative exposure to help identify where more additional funding is needed or resources are needed. So the next slide. So this is a visualization that kind of summarizes the data that we have in the tool. It is the summary installation data. It's kind of busy. It has donuts on the left and pies on the right. And I'll start with the top row, which shows for this installation 4 little colored dots near that upper red arrow. And that shows that this particular installation is located in the top half of the exposed installations, where the open circle is less exposed and the dark circle is more exposed. And then within each of the pies below is the weighted order, weighted average score. That's the index that we use to rank the exposure to the different hazards. So you can see that from lower 2050, which is in the top circle, the score is 424. Moving on to higher 2085, the bottom pie there, that's, donut, that's 501. So generally what we see is that we're increasing in hazard over time and with scenario, from lower scenario to higher scenario. The size of each of the areas within the chart is related to the legend below. So wildfire is orange, for example, and you see that the wildfire actually gets a little bit smaller in the future, and that's because other hazards are getting larger. The pies themselves are used to help understand the contributions of the various impacts to various hazards to the overall score on the donut on the left. So Here, for example, if we look down the heat column, which is the 5th column over with a kind of an aqua thing on the left and brown and buff on the right, you see that there isn't much change over time between the contributions of heat to that vulnerability score. But if you look to the left of it with riverine flooding, you see that the riverine flooding has a very large blue portion there, extreme precipitation day for the lower 2050 and higher 2050 scenarios, whereas the green indicator, which is the maximum one-day precipitation, is a larger contributing factor for the 2085 scenario. So what we can see at a glance looking at these pies is the kind of contribution to the overall exposure. Now, in the tool, whenever you hover over any color or any wedge or any piece of any color down in the legend, you'll get the information that's tied to that specifically. So if you go to the next slide, we should see, all right, so here I've hovered over this magenta square, which is under coastal flooding, and it gives a description of the coastal flooding, what this means, and then it gives the indicator contribution, which is 76% here. So the historic extremes I want to add, the second to the last pie to the right, is static because that's the historic information. So it doesn't change, but it does contribute to overall exposure. So next slide. So also here, what we can see is changing exposures. I just mentioned, if we look at wildfire, the first pie in the pie chart, you see this large red circle, which is the drought frequency here. It's changing when you get to between all the earlier 2050 and 2085 lower scenario and the 2050 higher scenario. It changes significantly when we get to the higher 2085 scenario, and this means moving out into the end, this fire season length starts to play a bigger role in the overall exposure. So each one of these contributing factors or indicators can help identify what's the larger contributions, and then you can start to think about what you might do with that information when you're considering mitigation measures. So next slide. So I want to talk a little bit about the riverine flood mapping. In this tool is a combination of FEMA mapping and Corps of Engineers 2D HEC-RAS modeling. The reason is if you look at the installation on the left-hand side, the installation boundary is shown in red. The FEMA mapping is the light blue area, and it really misses all the tributaries on the installation that could be important to installation management. And on the right-hand side, what we see is the same thing with the FEMA mapping merged with the the HEC-RAS modeling, 2D HEC-RAS modeling, which gives you much more of an idea of what kind of inundation you might be facing for different kinds of events at different locations on the installation. So the next slide gives an idea of how this is shown in the tool. On the left, we have the four pictures here. This is Kings Bay. The top column there is 2050, the lower is 2085, the left is the lower scenario, and the right is the higher scenario. And this is zoomable so that you can zoom right into the installation and take a look at different roadways and get an idea of what this looks like. Now, clearly, this is not for engineering design, but it is usable to at least see where does it look like we're going to be impacted in the future. Another point here to consider is that the inundations shown for riverine are the 1% annual flood plus, excuse me, my phone is going off. The 1% annual flood plus 2 feet and plus 3 feet. And that freeboard analysis is the kind of information that we'd be using per the NDAA. Also, on the right-hand side, you can see that we do include this information in the DISD portal. So we have shape files for each one of these inundation maps, riverine and coastal flooding, and that you can pull from the DISD portal for yourself. And then the coastal flooding uses the dorsal database, Defense Regional Sea Level Scenario database, to help do its inundation mapping. Next slide. Okay, so I just want to ask Pam for something. So you said we had 8 minutes. Are we ending in now, or do I have 8 minutes left, or what's the timing here?
No, ma'am. We're good to go. So please, no worries.
All right. So the idea here is that within the tool we can look at relative exposure. We can look at all the departments, or for a single department, we can look in the region. Here I'm showing the Southeast region. And the region here is determined not by a department region, but by the National Climate Assessment region. So we're defining climate regions that we would look at. And what we see here on the upper row is the lower scenario. The bottom row is the higher scenario, 2050 on the left, 2085 on the right. What we see is along the coastline, basically you see more of the yellow to orange, which in our legend on the right is meaning a higher weighted average score. So in other words, more exposed to the hazards that we're looking at. And here we're looking at all hazards. And basically you're increasing in hazard from 2050 to 2085, and you're increasing from a lower scenario to a higher scenario. So next slide. And again, if you hover over one of these, you'll be able to see the installation and its particular score. So I'm showing drought here by looking at the scenario, and the reason for that is that drought turned out to be the hazard that really impacted all the departments the most. And here in the Southeast, there's, it's one of the areas, Southeast and Southwest are one of the prevalent areas where which is true. And you can see that there is a great increase in the exposure going from earlier to later and from lower to higher scenario. Next. So the preliminary results of the tools when we aggregate the weighted average index scores gives us an idea of how the exposure is behaving between the time periods and the scenario. So here on this graphic on the right, the gray is the base period. This is the distribution of the WAWA scores here for the base period. The light blue is the 2050 lower. Right next to it, you see the yellow, which is the 2050 higher. So this is pretty much the 2050 scenarios. And then you see this darker blue, which is the 2085 lower, and then the 2085 higher shifted farther to the right. So a shift over to the right in these distributions means that you're getting more exposed over time. What you see is that the 2050 scores in general are fairly close together, the lower and higher scenarios. And this means that there isn't much divergence in climate expected before 2050, and where the major divergence happens is afterwards. And that's why the dark blue and the red line are farther apart. So next slide. So here I'm showing the same kind of a graphic, but for each of the departments. And as one might expect, the departments differ in exposure, and this is partly due to the nature of their operations and their missions. So on the left is Army, and here again, we have the 2050 lower is the light blue line. The darker dashed line is 2085 lower. The yellow line is 2050 higher, and then the red is 2085 higher. So here what we see is there's not much change between lower and higher at 2050, and then the 2085 scenario doesn't differ much at a lower warming, but at a higher warming there's a significant difference, and that's a real big change in the exposure for these installations. In the center we see Navy, and partly due to the fact that Navy is generally right on the water, there is a larger distribution of higher scores for them, but the same general trend of pretty much the same scores except for the 2085 higher scenario. Then on the right, we see Air Force, and Air Force has pretty much generally the same kind of distribution, except that it does tend to have this little peak out at the end of the 2085 higher that you can also see in the higher scores for the lower installations, and that's pretty much because they really have a requirement for a lot of flat land so that inundation impacts them out in that extreme level. So next chart. So the score distribution by hazard changes too, just like you saw in the different SACS information presented earlier. So here on the upper left, riverine flooding, again in the 2050 region, pretty much the same, but it gets bigger out farther out you go in time. Drought on the upper right has a much different profile for the high scenario at the end of the century than for the others. And this bears looking at because of the energy and water resilience planning that installations need to do. In terms of energy demand, you don't see that much of a change across the installations. But you'll see with heat that there is a difference, again, similar to drought, that the heat is has a different distribution that results in higher exposure later in the century. Next chart. So if we look at indicator contribution, we can look at, in this case, a higher scenario, and I'm looking at the wildfire because wildfire is important in the Southeast. And if I look at the flash drought flood frequency indicator, I can start to see how that might play into the exposure for these installations. There's a lot of work going on in wildfire and research, and of course with the Air Force's wildfire management group. So here again, you can see the same pattern increasing towards the orange-red from 2050 to 2085 at the lower scenario, and then the same increase at the higher scenario with an overall increase as you go out in the century at the higher scenario. So not a surprise here. Next. Here I'm looking at high heat index days, and I've gone back and looked at the national one here, so you can see that the Southeast is really an area where we're already vulnerable, as shown by the magenta in the upper two panels, where 2050 is on the left and 2085 is on the right. And high heat index days, of course, are important not only for your training and for health, and for energy demand. So for public health, it is a big deal. For training, it's a really big deal. And then when we look at the bottom figure, though, what we see is that the percent change in indicator value is basically everything is moving towards more exposed, every installation that we looked at so far, with especially dark areas up in Alaska and in the northern tier of the United States, where the heat impacts are really changing more than elsewhere. So next. Here we're looking at the high heat index days just for the Southeast area, so they can get a look that in the upper area with the magenta, we're more exposed at the 2085 on the right than on the 2050 on the left, and that there are a lot of changes both along the coast and inland, and these changes can help us understand what steps we might take to minimize the impacts to missions and operations. Okay, next slide. So how do we use this information? Example I'm showing here is for Army with their Army Climate Resilience Handbook. And the idea is not that you would separate climate as its own separate thing. Clearly, it's tied into all the other kinds of decisions that are made on installations. And so for planning here, what the Army has done is laid out what's the kind of climate resilience information that you would get, not only from this tool, but from other studies and other information, such as what you've seen on the SACS study today, and how you would move that into the real property master planning process, and then into the installation energy and water resilience process, and then moving on to the right into your natural resources management plans. So the idea is that climate feeds into all these plans. You've already got a structure within the departments to deal with those, and each installation is familiar already with doing these plans, and it would be an update or a change based on new information. So next chart. So in the end, we have basically the three different handbooks. You already saw the Air Force playbook on the right-hand side. Navy's came out in 2017. And then, of course, the Army's came out also this year. We're adding additional installations in phase 2, and we're meeting with the discipline working groups to provide additional information as appropriate for them. And given the change in administration and the kind of the intent in Congress that's been shown by the last few National Defense Authorization Acts, we expect increasing attention in the next several years for installation climate resilience. So that's my last slide.
Okay, thanks, Kate. We can move into the questions. We do have several questions in the chat. The first question, for projects or studies that will be underway prior to release of SACS products, is there a recommendation on how to be most consistent with the analysis that will be done with the benefit of SACS? And I'm going to pass this question to Matt. Are you there, Matt?
Hey, this is Matt. Sorry. Yep, in answer to that question, I would say to, first of all, take a look at that Tier 1 risk assessment. The link was provided earlier on. And just see what you're finding at the Tier 1 level, which is the regional level. Definitely follow up with us after you take a look, and you can ask what other products might be available to kind of add to what you're looking at. It depends on how far out your assessment is going to be finalized. We may have additional products that have come in by that time that we can provide or we can kind of discuss. But the first stop is taking a look at that Tier 1. It's publicly available, so it's out there, and that's definitely the first stop. Thank you.
Okay, thank you. Are impacts to military missions a category that goes into defining risk? For example, Onslow Beach is the only complete amphibious training area on the East Coast. Although not very developed, it is mission essential. Matt, do you want to answer that one as well?
Yeah, I can take a shot. And I want to tie into, I think that there was a previous question about Onslow showing up as low risk. I want to point out that the Tier 1 risk assessment is looking at inundation, storm surge inundation risk. So particularly oceanfront areas that may be at relatively higher elevation, they might have other hazards that they would be exposed to, such as erosion. And those areas aren't necessarily going to show up as higher risk. I'm not saying that that's the case in Onslow. I just wanted to point out that the Tier 1 is only looking at storm surge inundation. For various reasons, we want to be sensitive to pointing out, vulnerabilities of installations, particularly in documents that we're putting out to the public. And so what I would say is that there's definitely room for follow-on analyses by, from the districts in coordination or in partnership with the installations to use SACS data so the installations can pull that into their specific assessments. With the North Atlantic Division, there was a lot of follow-on action after the North Atlantic Coast Study where the Corps did specific work for installations similar to what Dr. White was talking about. And so those opportunities are out there. But keeping in mind that this particular report the information will be publicly available, et cetera, I think that ties in as an answer to several of the questions that were asked. Thank you.
Yeah, I do see a couple of other questions that kind of ask that same thing. So next question, can you please explain the rationale for applying 3 feet of sea level rise? Is that consistent across the SACS study region?
Is that for me?
You or Trevor, whoever.
Or Drew. We have Drew on the line. I think Dr. Drew Condon could answer that too as our engineering lead. Drew?
Oh, can you hear me? I think I just unmuted.
Yes.
Okay, great. Sorry. Yes, so the 3 feet of sea level rise, really we have our core guidance with our 3 sea level change curves, and being the size of this study, we had to kind of take a regional approach to that. So the 3 feet is in line with about 100-year projections following the intermediate curve and about 50-year projections following the high curve on a regional scale. So certainly there'll be some deviations from that once you get specific to a specific location, but overall that was the uniform number to use. And the thought is that in a tier 2 analysis or higher analysis, maybe localized numbers could be used for sea level rise estimates.
Okay, thanks, Drew. What kind of information can installations provide to increase the effectiveness of economic modeling? I'm not sure if we have Idris on the phone on the webinar.
I can take a shot at that, Christina, if Idris isn't on.
Okay.
So what you saw in several slides as far as the Tier 2 economic risk assessment, that relied on civil asset data. So generally replacement cost, less depreciation, or the value of assets. Again, assets that may be on installations, since this is going to be a public document, there's sensitivity to that type of information. That said, a similar type of assessment could be done specifically to installations as a follow-on. Idris, I don't know if that's you who unmuted, if you'd like to clarify anything I said.
Yeah, this is Idris. I'm here. I was trying to unmute. What was the question again?
Hang on, let me go back to it, Idris. What kind of information can installations provide to increase the effectiveness of economic modeling?
Oh, so if that's direction that we would want to go, then basically what we typically use is the depreciated replacement value of structure.
Okay.
And I just want to echo, Christina, this is Pam. I appreciate that, Idris. I just want to echo Matt's comments. Under the SACS, our data sets were primarily civil data sets.
Sorry about that.
So
can you guys hear me? It dropped my call. Sorry about that. You guys, Pam, you were saying something?
Yes, Idris. I was just clarifying. I think Matt made this comment earlier as well, that the SACS is not doing that type of a detailed economic risk assessment on the installations specifically. We were using larger scale civil data sets, but I think as a follow-up, if there's interest in getting a little bit more information on that.
And the silver jacket successfully completed or very close.
Somebody's got a hot mic, please. Thank you. Please go ahead. Please feel free to reach out to the district project manager that's overseeing the work that's being done in that specific state, and we'll be glad to engage in some further discussion on how we've completed those analyses and maybe follow on with some support work. Thank you.
All right, thanks, Idris. Did you have anything else on that? All right, we'll go on to the next question. Can installations be part of the working groups for with each state? Pam, did you want to answer that?
Sure, Christina. If there's an interest in being part of those working groups, again, I would definitely encourage you, reach out to the district project manager. We do have that contact information on the last slide of this presentation, and there are opportunities to be part of that dialogue. So reach out to that project manager and make that request, or please go ahead if specifically you're interested in that and indicate that in the chat function. We'll circle back with our team members and ensure that you have an opportunity to follow up.
Okay. Next question, will the NACS be updated with similar tools? And I do not believe so.
Yeah, I'm not aware. This is Pam. I'm not aware of any plans to update the NACS. That study is completed. There were a lot of high utility, extremely useful products that were developed as part of the NACS. But at this time, I'm not aware, and I appreciate your thoughts too, Christina. I'm not aware that there are any plans to actually reopen the NACS and update any of those products.
All right, I don't see any other questions. Matt, did you need to say something? Lisa, can you unmute Matt Schrader?
Nope, I'm good. I was just muted, couldn't unmute myself, just in case I had another question. Thanks.
Okay. We just have, it looks like we have one more question that came in. Bird airstrike hazard, or BASH, is associated with wetlands nearby airfields. In coastal areas and given the imminent sea level rise, has there been any studies or documentation of groundwater rise with the rise of sea level that subsequently produces wetlands and BASH? I'm not sure the answer to that question. I am the environmental lead, but I am not familiar with what BASH is, so I can definitely follow up with you on that question. Okay, I don't see any other questions in the chat. Do we want to, Lisa, do we want to go to the poll really quickly? Okay. So Lisa is going to put up a poll, and it is going to ask, you know, if you have interest in any of these key study products. And the poll will allow you just to write in the study product that you have interest in, that you would like us to follow up with you on. So we're going to give a minute or so for you to type in your response here.
I would just like to note that you may need to open your chat box in order to see the polling if it doesn't automatically appear. Thanks. Okay, we've got just a few more seconds remaining. Some more answers are coming in. And we're just waiting for those responses to be submitted. We're going to go ahead and give it just a few more moments. Okay, Christina, can you see, I've published the poll results. Are they showing?
Lisa, I do not see the results.
Okay, so this was a short answer, and so it very well may be that we'll have to download this and then do an analysis, and I'll make sure that I save that now. I apologize. I thought the short answer would, in fact, publish the answers. But we'll definitely make sure to get back to you because it is tracking your name and whatever you typed in the poll. So thank you very much for participating in that.
Okay, thanks, Lisa.
Okay, Lisa, I think we're ready to go on to the next slide then, our final slide. All right, so actually that's absolutely perfect timing. It looks like we're at the bottom of our 2-hour webinar, and I'm pretty confident that we met our goal in sharing with you what the SACS is about and the DoD Climate Assessment Tool as well, what they bring to the table in terms of supporting your efforts to reduce risk and enhance resiliency at your facilities. This slide contains the contact information for our command center team and our district PM, so again, please reach out to the district PM in the state or territory in which you're located for more information, more details, kind of follow-up discussion on either the application or the accessing of SACS products. Dr. White's contact information is also on this slide for any follow-up questions about the DoD Army Climate Assessment Tool. We will be having a webinar coming up next month at which the sand availability and needs determination products are going to be showcased in detail. As Lisa mentioned, we're going to analyze the feedback we got on that last slide in terms of products that are of particular interest to you. And as we move forward, we do external quarterly webinars. We're going to be showcasing these products. We're going to use that feedback to determine which products to offer those webinars on. And we, of course, will include you on the invitations for those webinars in the event that you're interested in a particular product. So with that, I'd like to thank you all for being with us today, for your participation and time. I know it's extremely valuable. And I'm going to wrap up today's webinar with wishes for everybody for a safe and wonderful holiday as we kind of peel off to enjoy time with family and friends over the next couple of weeks. So thank you so much. Again, we appreciate your participation today.